Hmm. When we talk about the electrochemical cell, right? Electrochemical cell. Electrochemical cells are what? Electrochemical cells are those cells which convert chemical energy to electrical energy. Hmm. Or it can convert electrical energy to chemical energy, right? Right, is it clear to you? So that's a very important portion we have to nurture, right? So this is very important that if you see when we talk about when we try to talk about the electrochemical cells, right? Electrochemical cells can be of two types, right? The two types are what? One is called the Voltaic cell, and one is called the electrolytic cell, right? You have to understand this difference, right? So if you understand if you go to that, if you go to the electrolytic cell, right? Sorry, electrochemical cells, right? So electrochemical cell will be of two types, right? One is called the Voltaic cell, and one is called as a electrolytic cell. What happens in the Voltaic cell? In the Voltaic
Chemical
cell,
energy due to
chemical
electric.
energy as spontaneous chemical reaction is getting converted to electrical energy, right? Fine. You get my point. And what's happening in the electrolytic cell? Here we are seeing that the electrical energy, right? The electrical energy is forcing a non-spontaneous reaction to happen. Means it is converted to chemical energy, right? You get my point? Suppose if you leave NaCl on a plate, will it automatically getting converted to Na plus Cl2? No, this is cannot, right? So it's a non-spontaneous reaction. So can we force this reaction to happen? Yes, we can force this reaction to happen. We can force this reaction to happen by what? By doing by
Mhm.
running an electric current, right? Clear? This is clear to you. You can force
Yeah.
this reaction to happen by passing an electric current, right? Is it clear? Understood? By passing
Uh,
electric current. So this is called as electrolysis, right? And if you see the electrolysis, now this point you should master. Please try to note down this. Voltaic cell, if you tell, Voltaic cell, see cathode and anode, right? Note down
yeah.
this, right? Now in this thing you have to understand that the cathode and the anode, right? The both the cells, right? If you say electrolytic cell, EL cell, hmm, in both the cells, right? In the both the cells, you're seeing that the cathode will be always undergoing reduction, right? Both the cells, right? Reduction. And anode, what happens? Anode will be having what? Oxidation, right? Clear? Oxidation, right? Did you get my point? Anode will be suffering oxidation.
Right, yeah,
Now
yeah.
remember one thing, that over here, if you see that if you see a anode, right? Anode will be, the sign will be different in both the cells, right? Hmm. But the sign in the Voltaic cell is negative, and
Negative.
cathode is. But this thing you have to master, right? Many questions comes, right? And what happens in the electrolytic cell? Cathode is negative and anode is positive. Clear? You get my point? These two are clear for you, right? Understood this part? So it's a very
Yeah.
important information we have to draw, right? Isn't it? Now going to this thing, now we understood that in the Voltaic cell, there's a chemical energy, spontaneous chemical reaction. Chemical energy getting converted to electrical energy, right? See the examples of the Voltaic cell? A battery, right? Any battery, dry battery, or you have got a car battery, right? You have got a laptop battery. These are all Voltaic cells, right? Now, electrolytic cell. Electrolytic cell does what? There's a non-spontaneous reaction happening. We are forcing it is happened by passage of electrical energy, right? And chemical energy is obtained, right? Clear? This is clear to you? Understood this part, right? Fine.
Yeah.
So now going to this thing, now if you see when we talk about this, right? We have to understand that whenever we are seeing electrolytic cell, right? Electrolytic cell will be different. You have to understand. Voltaic cell, if you see, Voltaic cell will be having two tanks like this, right? You'll be able to understand, right? And a solid bridge will be there. You can understand that is it Voltaic cell or electrolytic cell. Two tanks will be there in the Voltaic cell. Yeah, electrodes will be there. That's okay. And a voltmeter sign will be there. You can understand the difference. Whereas in the electrolytic cell, a single tank will be there. Understood? Do you get my point? A single tank will be there, right? Get my point? A single tank. And in the single tank, you'll be having what? The electrodes attached, right? And a battery sign will be there, right? Fine. Just remember this thing, that the process will be the same, right? Now, what if this is an anode, right? I'm writing anode and cathode. Now write down this, right? Both the cells. I forgot to tell one important thing, right? This is anode, this is cathode, right? Indeed. Right? In the both the cells, you'll be seeing what? The electrons is going from the anode to the cathode. Is it clear? Always, right? Please write down both the cells. Electrons move from the anode to the cathode, right? In the electrical wire. This is both. This is common for both, right? Clear? Is it clear to you, right? Did you get my point, right? Is it clear to you? Fine.
Yes.
Understood this part, right? So that's a very important part we have to understand, right? Now going to this thing, now you to see that when we talk about, right, when we talk about this, right, we have to understand that if you're seeing that the electrolytic cell, we have got two important things to be handled, right. First is that the electrolytic cell, we will be seeing that molten ionic compound you can take. Understood? Second is that you can take a ionic compound solution. Understood? Clear? Do you get my point? Understood? Right? Do you get my point? It can be two types: molten ionic compound and aqueous ionic compound. That'll be better, right? Clear? This is clear to you, right? Aqueous ionic compound, right? Understood this part, right? You get my point? Electrolytic cell can be of two types. Means molten ionic compound you are taking means only NaCl, right? Suppose I'm taking only NaCl, right? Just remember this thing. Suppose I'm taking NaCl aqueous solution. Can you tell me what is the difference between this and this? This is molten, see, liquid.
Yeah.
This molten ionic compound, does it have water in it? No, it does not have water, right? This is the difference. And in aqueous ionic compound, right? You've
It
seen
has
the
both.
water is there, right? Fine. Get my point. Water is there. Do you get my point?
Yeah.
Understood this part? Water will be there, right? Is it clear? So it's a very important portion we have to master, right? Clear? Any
Yeah.
questions, please tell me. Is it clear to you? Fine?
It's clear.
Fine? Lovely, lovely. Now see, now if you see that the products, right? The products. Now, my advice, when you are doing electrolytic cell, don't try to compare with the Voltaic cell. Never, right? Don't try to compare with the Voltaic cell, right? Never ever. Hmm. Fine. Now see. If we see when we talk about when you talk about the electrolytic cell, right? The products will be can be predicted, right? We can predict the products, right? Now this is for aqueous ionic compound, right? Isn't it? Fine. Now if you see whenever we are taking any aqueous ionic compound, what's the sign of the anode? What's the sign of the anode in this electrolytic cell? Positive, right?
Positive.
The sign of the anode cathode in the electrolytic cell? Negative, right? Clear? Negative, right? Clear? This is clear to you? Will be negative, right?
Yeah.
Understood this part till over is clear to you? Fine. So it's a very important portion we have to learn, right? It will be negative, right? Cathode will be negative, right? Clear? Okay. Now, now the next part is that if you see when we talk about when we talk about the products in the anode, always oxygen or a halogen will be given out, gas, any one of them. In the cathode, see, always a metal or a hydrogen will be given off, right? Now we might be wondering that, okay, what does uh, does the rule says, how does it how we can predict that, okay, oxygen will be given or halogen will be given, the metal will be given, hydrogen will be given, right? What can we predict, right? How we can predict, right? That's the thing we have to understand, right? Now given this thing, we have to see that when we talk about the product, right, we can predict also, right? Now now remember one thing, that if you see this particular example, right? Mm, see, if we see that when we talk about some examples, right? Suppose I'm taking copper chloride, right? Right,
Yes.
suppose I'm taking copper chloride, it gives you chlorine gas, right? And copper metal, right? Now, so suppose I'm taking sodium chloride, we expect over here sodium metal, it's not coming, right? We expect sodium metal is not coming. Hydrogen gas, question mark, right? Okay, chlorine gas is given out. Now if we take suppose copper sulfate, I'm giving the example copper sulfate over here, right? It should give some gas similar to, but it gives what? It gives it gives what? Oxygen. Stunning, right? Yeah, copper metal given, right? So we are in a doubt that, okay, what guides the products, how the products are guided, isn't it? What guides the product, right? So that's the reason we have to know that what guides the product. So in your IBDP HL chemistry, we have to know that there are two aspects you have to know, right? First aspect is what? The type of the product, right? This is very important. The type of the products, right? What is given? Is chlorine gas given or oxygen gas given? So we have to divide this thing into two parts, right? What is obtained at the anode? What is obtained at the cathode? Is it clear? Right? Two particular divisions we have to do, and separately we have to handle. Now, in this part, we are handling that what is given out the cathode, right? What is given out the cathode? What exactly do we get the cathode, right? So for the cathode, we have to see that Suppose we are seeing, suppose we are taking, suppose NaCl, right? Now concentrate on this, right? And open your data booklet also quickly, right? Open your data booklet to, wait, um, just give me a minute, 1 minute. Yeah, open your data booklet to 19 number, right? And remember this thing, right? 19 is that, right? Isn't it? Now you have opened, right? Hmm.
Yes.
See, now if you see that when we take, suppose NaOH, right? Suppose you're taking NaCl. Now we know that if you take NaCl solution, what happens? Water will be separating them out. Understood? Into what?
Yeah.
Individual ions, Na plus and Cl minus, right? Yes, we
Yeah.
write AQ for that. But also, do you know what? Water will be there as a dipole, right? Water has got a polarity, delta minus plus, right? Delta minus and delta plus, right? Do you get my point, right? If you take NaCl solution, right? What are the ions which are having? In this beaker, we'll be having what? We'll be having Na plus AQ, right? Understood? Na plus AQ and Cl minus AQ. And along with it, what do we have? We have water also. Water also, isn't it? This is delta minus. This is delta plus. So
Yeah.
water will be attracted to both the electrodes. Did you get my point? Water will be attracted to both the electrodes, right? Right, isn't it? So
Yeah.
this positive part will be attracted to the cathode, and water will be attracted to the cathode also. And
Yeah.
anode, what happens? The negative, delta negative will be drawing towards the anode, right? You get my
Yeah.
point? So over here,
Yeah.
we are seeing a situation where in the molten NaCl, right, there was no competitor, right? There was no competitor. Only Na plus going to the cathode and Cl minus going to the anode. That's it. But whenever we are taking an aqueous ionic solution, right, water will be there as a competitor. Do you get my point? Water is a
Yeah.
competitor over here. So we have to see that. We have to see individually case we have to go. First, I'm handling cathode, right? Understood. So who goes? Na plus goes and H2O goes, right? Now, this is very important that if we see that you have to compare the reduction potential. In our data booklet, we are giving reduction potential, remember, not oxidation potential. Reduction potential is given. Means all the cathode reactions are given, right? So what we have to draw out? We have to draw these two equations, right? We're taking this equation and we are taking what equation? This equation, right? Isn't it? You can open up a book and write down. This is the cathode reaction of water. This is the thing we have to compare, right? Do you get my point? And now see, we are plugging in this formula. D is equal to minus NFE, right? Understood? Means we want to find out which reaction is spontaneous. Both cannot go to the cathode. Agreed? Both cannot go to the cathode. Both cannot go. Only one of them will be going. So who guides it? The Gibbs energy guides it, right? So we know that if the Gibbs energy is negative, more spontaneous is the process, right? Isn't it? So can we find out that which of the reduction reactions is more spontaneous? Can we find out? Yes, we can find out that which of the reduction reactions is more spontaneous, right? So which of the reduction reaction is actually spontaneous? We have to find out that where the E, see, this is minus NFE. So where the E is what? Where the E is more positive. Agreed? Agreed to. Positive into negative will be given negative. So the reaction is spontaneous. Understood? Clear? Now tell me one
Yeah.
thing, which one of them will be going from here in here? Which is more
Mm,
positive? You have to compare that. Which is more positive? Because we are comparing the cathode reaction of water.
and will give half H2.
So and hydrogen gas will be evolved. Sodium does not go. Is it clear to you? Did you answer this
Yeah.
part? Right? And sodium won't go, right? So this is a very important observation we have seen, right? For the cathode, we have to compare what? We have to compare which is the more positive one. So can we have a corollary also that that more reactive metals, they do not go to the cathode, they stay back. Clear? Because they have become very negative reduction potential, right? Now come to the separate case, second case. The second case is what? You are taking copper chloride, right? When we are taking copper chloride, what happens over here? If we take this per copper chloride, copper will be rushing and water will be also. Now same thing, we write down the reduction potential. So we are taking what? We are taking the more positive reduction potential. Why? G is equal to minus NFE, right? Which is more positive. That will be going to the cathode, right? So see what happens? Copper will be getting deposited. And there, in the earlier case, sodium did not go because it has got a higher negative potential, right? So we can infer that more reactive metals, they do not go to the cathode, they stay back. And very less reactive elements such as copper, since they have got a more positive reduction potentials, they go to the cathode. Is it clear? Did you get
Yeah.
my point? That very reactive metals, what we saw, is having what? Is having very negative reduction potential. Thus, it won't go. On the other hand, unreactive metals such as copper, silver, they will be going because they will be having a positive reduction potential, right? So this
Yeah.
this was the chapter about the cathode product, right? Now go to the anode product, right? Now, if you suppose there's a very good case study over here, right? That suppose I'm taking NaI, right? Suppose NaI, aqueous solution. So in the solution you're having what? Na plus H2O rushing to the cathode, and I minus rushing with along with H2. Agreed. I minus rushing with along with H2, right? It's clear, understood. So it's a very important information we have learned, right? We already discussed about the cathode, did we? We discussed about the cathode already, right? Now anode we see. Now what next we do? We have to pull out the what? Pull out the anode reaction of water, right? You get my point? The anode reaction of H2 is what? This one, right? O2 plus 4H plus 4E is equal to 2H2. This is the anode reaction of water we have to take. And we write down the reduction reaction of I2. Now here we have to learn a trick. In anode, they both go to the anode. And what happens in the anode? Can you just guide me? What happens in anode? Oxidation happens or the reduction happens? What do you think?
Anode.
Cathode, what happens? Red cat happens. I told you that rhyme, right? Red cat happens. So reduction happens in cathode.
Oxidation.
Oxidation happens, right? And these are what reactions actually given? Please tell me what reaction given over here?
These are
Reduction reactions, right? So,
irreversible.
so what you have to judge for? From these two data, now write down this. From these two data, which is more negative, right? That will be going, right? Please write down this, right? More
Yeah.
negative. This trick you understand, more negative. This trick that will be solving a case. More negative will be going to the anode. And who goes? Who is more negative? This is more negative, right? Fine. So oxidation reaction we have to write. This is reduction reaction. So what we have to do? Please guide me. What you have to do?
Flip.
Flip the
Flip the
reaction.
sign.
Brilliant. We have to flip the reaction. What we get? 2I minus gives you I2 plus 2E, right? Isn't it clear to you? Understood this part, right? So
Electron.
that's the thing we are seeing, that we have to see what? We have to
Doesn't
see
it
that.
become minus 0.54
Yeah,
G?
yeah, yeah,
Yeah.
yeah, yeah, yeah. Yeah, very good, right? Isn't it? Fine. So we have to just catch the product like this, right? Now we're going to the next part, right? If you see now know this important part, that if you see that if you have got sulfate, right? Please note down this. Please note down this. If you
Yeah.
have got sulfate or nitrate, please write down sulfate or nitrate. Sulfate or nitrates, they do not go to the anode. Is it clear? Why? Because they are in the highest oxidation state. See, understood? They cannot be oxidized further. What happens in anode? Tell me. Oxidation happens, right? So in
Yeah.
sulfate or nitrate, they are sitting in the highest oxidation number, right? Plus
Yeah.
6 and plus 5, right? Clear? Understood? Sitting in the highest oxidation number. So they cannot be oxidized further. So these does not go. Is it clear to you? Do you get my point? Suppose I'm giving an example. Copper sulfate. So who is there? Copper 2 plus is there, and sulfate ion is there, right? This is a past paper question I'm discussing, right? And over here you're having H2, you're having H2. So who goes to the anode? Sulfate and H2. But as I have told you just now, the sulfate and nitrate, does it go? Does it go? They do not go,
No,
right?
sulfates and nitrates don't go,
So
sir.
do not go. So will not go, right? So who goes? Water goes. And what is the reaction you have to pick up? You have to write down this reaction. H plus E gives you uh,
Half
H2.
H2 plus. Yeah.
This part, huh? This part, this bit. And you have to flip the reaction, right? Obviously, right? Clear? So oxygen is released. Got it? Is it clear to
Yeah.
you? This part to you, is it clear? Now going to the concentration part, right? Now learn that when we see the concentration, right? If you see the concentration, learn this trick. For concentration, learn this thing, that who is more in population, right? Please learn this thing. Who is more in population, right? Population. Fine. Will be going, right? Concentration. Suppose I'm taking, suppose 0.1 moles per decimeter cube NaCl solution, right? This is a concentrated solution. Always remember this, right? Got it? Suppose I've taken 0.001 mole per decimeter cube NaCl solution. This is dilute solution. Understood? Clear? Get my point? So if we see that, suppose I've taken a NaCl concentrated solution, right? Understood? The cathode reaction will be remaining same. Write down this. Remaining same, cathode reaction. The anode reaction will be influenced, right? Isn't it? How does it influence? Who rushes to the anode? Tell me. Cl minus and H2, right? Now,
Yeah.
because it is concentrated, who goes? Who is more in per number? Tell me. Cl minus or H2? Who is more in number?
Cl minus.
Cl minus. So Cl minus will be going, right? And you have to pick up that reduction reaction and flip it. We get Cl2 gas. Understood? Water does not go. Clear?
Yeah.
Understood? On the other hand, if you see, suppose I'm taking NaCl dilute solution, right? If I've taken NaCl dilution, who is more in number? Please tell me. Population is more, he will be going. Who is more in number? In dilute solution means you're taking little bit of NaCl and huge amount of water, right? That's a dilute solution, right? Huge water you're taking, right? Clear? You're taking a little
Yeah.
bit of NaCl and taking huge amount of water, right? That's NaCl solution. Understood? So understood. So which is more in number, Cl minus or H2 in dilute NaCl? You'll be giving these numbers, right? 0.001, 0.0001, right? These tell you that dilute solution is there. Who goes? Who is more in number? Tell me.
H2.
H2 is more in number. Very good. You have taken huge H2. See, a little bit spoon of NaCl, right? You get my
Yeah.
point? Little bit spoon of NaCl, right? Do you get my point? So what happens? H2 will be going, right? And what reaction to pick up? We have to pick up this reaction, right? 4H plus 4E gives you H2O, right? Is it
H2O.
clear to you?
Yes.
And you have to flip this. To flip this. And what is obtained? Tell me. O2 is
Oxygen.
obtained. Yes,
Yeah.
yes, 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 yes. Fine. So type of the products we already discussed for cathode anode. Now remember one thing that I didn't mention you intentionally, but because you will be overwhelmed, right? Type of the product, we understood cathode, we discussed anode, right? Type of the product is also influenced by the type of the electrode, right? Electrode. Please write down this, right? Electrode can be of two types, right? Electrode can be what? Electrode can be uh, unreactive, right? Write down unreactive electrode. Electrode can be reactive electrode. Is it clear? Understood? Understood this thing? Unreactive electrode and reactive electrode. Got it? Right? Unreactive electrode and reactive electrode. Unreactive electrode, how do you know? Please guide me. You'll be having graphite written, graphite, right?
Yeah.
Platinum, carbon, right? These are unreactive. Whenever a reactive electrode is given, suppose copper electrode, right? This will be given, right? You get my point? Understood? Now, all
Yeah.
we discussed till now was unreactive electrodes. Agreed? All we discussed was unreactive electrodes, right? Fine.
Yeah.
In the unreactive electrodes, this happens. This is a platinum electrode. You have to catch the language. So obviously we know that copper goes and deposit it, and sulfate ion does not go. So H2 will be going, and we bubble as water. Is it clear, everybody? Right? Is it clear to you? This clear? Now, if we take copper electrodes, now listen to this. If you take copper electrodes, now write down this. The cathode reaction won't get influenced, right?
Yeah.
The anode reaction will be. Only the anode reaction gets influenced. If you're taking
Yeah.
a reactive electrode, what happens? Neither, suppose I'm taking copper sulfate, neither H2O nor sulfate ions will be going, right? Neither of them, right? To the anode. Clear? Get my point? Neither of them will be going. Got it? Neither all will be going. Who goes? Who goes there? Tell me. Instead, copper from the electrode will be going to the solution as copper 2 plus ions. Do you get my point? Do you get my point? You don't have to read this, right? Oxidation potential and comparing, right? Did you get my point?
Yes.
Instead, what happens? Instead, tell me, copper from the copper electrode goes to the solution as copper 2 plus ions, means soluble ions, and going there, releasing the two electrons, right? Now, can you tell me with time, the copper electrode will be getting thinner and thinner, or thicker, or no change will be there? What do you think? Copper from
It,
the copper electrode will be going to the solution as copper 2 plus. So it will be getting thinner or
yes.
thinner?
Thinner.
Tell me. Thinner. Brilliant. Understood. Clear? Agreed? Right? Fine. Now we are going to the very important part next. Just few moments, right? This will. If you see that when you talk about the electroplating, right? There's a very good article which I sent to you. Did you receive that electroplating? Can you open your resources group? A very good article which I sent to you. You can go over that, right? See, if you're doing electroplating, what's the rule of electroplating? Can you guide me? What's the rule of electroplating? Mine? What's the rule of
Uh,
electroplating?
the cathode is the what's it called? What you have to electroplate, and
Electroplate.
anode
You
is
know
what
this.
you
Very
want to
good.
plate
Very
on.
good. Very good. Whatever object we want to electroplate with, right? We have to take at the cathode. Agreed? Fine. Whatever object we have to electroplate, we take at the cathode, right? Fine. And whatever we want to electroplate it with, we have to take at the anode, right? Clear? Now, the question is that what the electrolyte you have to take? Any guesses? Please write down. A soluble, a soluble metal salt solution you have to take, right? Clear? Write down this, right? Salt solution you have to take. Understood? Clear? Do you get my point? A soluble metal salt solution you have to take. Fine?
Yeah.
Fine? Now, how do you know that? Do you know what? I'm giving the example that that if you see that there are many salts which are not soluble, right? So how do you make sure that the salt is soluble? Now write down this. All nitrate ions are soluble, right? Nitrate ion compounds are soluble. You can write down that compounds are soluble, right? Clear? Is it clear to you? Suppose we
Yes.
don't know that silver sulfate is soluble or not. We don't know. We are in a doubt. So the safe bit is what? All nitrate compounds are soluble, right? Get my point? So we add what? Silver nitrate, right? Clear?
Y-
Over
Yeah.
here. And what the reaction happening? The reaction will be the silver ions from the silver nitrate will be going and getting deposited on the jug, right? And what did I tell you? That if you are taking a reactive electrode, nobody goes to the anode, right? Understood? Nobody is allowed to go to the anode. Instead, what happens? Tell me. Instead, tell me. Silver metal from the electrode goes to the solution as silver ions, right? Clear? Understood? Do you get my point? Instead, silver ions from the silver anode goes to the solution as silver ions, right? So with time, what happens? This anode will be getting thinner and thinner and thinner. Understood?
Yeah.
Understood? And what happens? We have to replace this silver, right? Understood? So that was what? That was this. So this is a very important part, right? That the object to be electroplated, you take the cathode. Anode, we have to take the metal, and electrolyte, we have to take the salt solution, right? Right? Is it clear? You get my
Yeah.
point? Huh? So that's a very important part we have to nurture, right? Do you have any questions which is there, right?